Hello again, Bio 10 students. So we're going to continue with our description of the atomic theory of matter. Remember, we started this in the last set of screencast videos where we talked about the basics of the atomic theory, which is that everything in the physical universe can be grouped into two categories. Either it's matter or it's energy. And matter is the substances that have weight. Matter is made of tiny little particles called atoms, which themselves are made of even tinier particles called subatomic particles, specifically protons, which are tiny little positively charged particles, electrons, which are negatively charged, and neutrons, which are neutral particles that have no electrical charge. Those three subatomic particles, protons, neutrons, and electrons, make up what we call atoms. All atoms are made of those same three particles, but there are different kinds of atoms that have different numbers of those particles. So we have last time we talked about the periodic table of elements, which is a listing of different types of atoms where the atoms are separated into different boxes based on what's called their atomic number, which is how many protons or positive particles they have in the center. Atoms with different numbers of protons are given different names. They're put in different boxes. So, for example, hydrogen atoms have one proton in the middle, whereas carbon atoms have 6 protons and oxygen atoms have 8 protons. We also talked about energy. And energy is the forces in the universe that move matter around. So energy is essentially just waves of force that push matter around. Matter moves because there's energy around moving it. Without energy, matter doesn't move at all. So fortunately for us, energy is everywhere in the universe. We have a tremendous source of energy here in our solar system, which is the sun. The energy from the burning sun is what essentially powers most of the processes in the universe, in the solar system, and especially here on Earth. The sun provides the ultimate energy for all living things. So energy is not made of atoms like matter is. Matter is made of atoms, but energy is actually made of waves of force called photonic waves. And depending on the wavelength of those waves, there's different kinds of energies with different wavelengths, and that includes things like light, which is a form of energy, and heat, which is another form, and X-rays and microwaves. Those are all forms of energy. Energy is essentially weightless, but it's made of waves of force that can push matter around. So we talked about the periodic table, but we also got into some detail about how, although you can separate atoms into different boxes when we're talking about matter, which is made of atoms, can separate atoms into different boxes based on the number of protons they have. But even within a box, one box, you can actually have different forms of an atom. For example, hydrogen atoms. What makes hydrogen hydrogen is that one proton in the middle. But there are actually different forms of hydrogen. In fact, on Earth, there are four forms of hydrogen that we can find. And those different forms of an atom are based on different numbers of electrons or neutrons. So the proton number determines the type of atom, but the electron and neutron number actually determines the form of the atom. So for example, atoms with the same number of protons and electrons are what are called neutral atoms. So a hydrogen atom with one proton and one electron would be neutral. But not all atoms have the same number of protons and electrons. So, for example, there's a form of hydrogen called a positive hydrogen ion, which has one proton but no electrons at all. So you can have, in each box, you can have neutral forms of the atoms, you can have ionic forms if there's a different number of protons and electrons, neutral forms if there's the same number of protons and electrons. You can also have what are called isotopes of atoms, where there's different numbers of neutrons in the middle of the atom. So the reason that chemists care about these different types of atoms, different forms, is because the type of atom you're looking at and the form that it's in actually determines its behavior. So today we're going to talk some about the behavior of atoms. In particular, their tendency to form groups with other atoms by creating what are called bonds. And in this way, atoms are kind of like you. Atoms are social, just like humans are social. And because we're social, we tend to seek out other humans and we form attachments with them or bonds with them. Some bonds are familial bonds, like families, and some are friendship, and some are more acquaintance, and some are romantic. We have all kinds of relationships that we form with humans because we're social and we have a need to connect with other people. And atoms are social too, and they actually have a need, and we'll talk about what gives rise to that. They have a need to form chemical bonds with other atoms to create groups. And in fact, the atoms that you find in living things are almost all in groups. That is, they're in what are called chemicals, which are groups of two or more bonded atoms. So when you find atoms inside living things, you don't find them alone. You find them in groups. Now remember, living things are technically matter. That is, all living things have some weight. And so they are in the matter category in the universe. That means they're made of atoms and subatomic particles. But again, the forms of life that we have here on Earth are all made of atoms that are bonded together in groups, so they're in what are called chemicals. So because biology is the study of living things, when biologists study life, and particularly the chemistry of life, they're looking at chemicals rather than individual atoms, because the atoms in living things are in groups. So today what we're going to talk about why atoms form groups with other atoms, why they don't just hang out by themselves. We're going to talk about the different ways that atoms can bond together, different kinds of groups they can make. And then we're going to talk about the chemicals, the groups of atoms that you find normally in all living things. It turns out that every living thing on Earth is made of a very similar set of chemicals. And that's one reason that biologists have adopted chemistry as an important subject, is because it describes what living things are made of, but also it unifies the study of living things, because all living things really are made of very similar chemicals. So at the end of this set of lectures, we're going to look at the chemicals that you find in all living things.